Hello everyone, my name is Gagandeep Singh and I am from Electrohack. You are watching the third tutorial on VLSI. In the first tutorial, we have studied about some basic introduction about VLSI and VHDL. Now in this tutorial, we are going to study about different modeling styles available in the VHDL. So VHDL allows us to represent circuit designs at different levels of abstractions. Depending on these levels of abstractions, the architecture of an entity to be designed can be described using any of the primitive style of modeling, but the entity will remain same. So the three modeling styles which can be used for describing the architectures are data flow style of modeling, behavioral style of modeling, and the structural style of modeling. So the first is data flow modeling style. This modeling style expresses the functionality of a circuit as a flow of data through bits and interconnections. This modeling style uses the logic expressions like A and B or C to express the flow of data from immediate interconnections called signals. This style of modeling is also called as concurrent style of modeling, as a flow of data is expressed using concurrent signal assignment statements. A concurrent signal assignment statement is executed whenever an event occurs on signals that are used in its expressions. Next is the example of data flow style of modeling. In this we are going to design 2:1 multiplexer. So the expression for 2:1 multiplexer is y is equal to s bar a plus bs, where y is the output and a and b are the inputs and s is the select line. In this we have used inverter, 2 AND gates and 1 OR gate. Here is the architecture code of the 2:1 multiplexer. Architecture is the keyword, mux1 is the name of the architecture, multiplexer is the name of the entity. So before going on to the architecture, we have to define signals. So s bar, s1, s2, which are in the standard logic vector, are used in the 2:1 multiplexer. So after the begin keyword, we have used sequential statements. So at the inverter, we are getting s bar as the output by applying s, and at the first AND gate we are getting s1 by applying a and s bar, and the second AND gate we are getting s2 by applying s and b. Finally, y as the output is taken by applying s1 and s2 at the OR gate. At last, we have to end the architecture by using AND keyword following with the name of the architecture. Next is behavioral style of modeling. This modeling emphasizes the behavior of a circuit, that is behavior of the output with respect to changes in the input, without going on to the details how or using with what components is functionality carried out. This style of modeling is also known as sequential style of modeling, as it uses sequential statements, and also the order in which the statements are written is particularly important. Also, this set of sequential statements specifies inside a process statement. A process statement also have a declarative part and a statement part. Here is the example of behavioral style of modeling. In this also we have designed 2:1 multiplexer. This is the expression of 2:1 multiplexer, and here is the diagram of 2:1 multiplexer. In this inverter, 2 AND gates and 1 OR gate is used. This is the architecture code of the 2:1 multiplexer using behavioral style of modeling. Architecture is the keyword, mux1 is the name of the architecture, multiplexer is the name of the entity. S bar, S1 and S2 are the signals which are used in the 2:1 multiplexer. Next is the begin keyword. So in this we have to write process statement. So in the process statement we have to write different types of signals on which the different operations to be carried out. So S, A, B, S bar and S1 and S2 are the different signals which are used in the 2:1 multiplexer on which the operations to be carried out. Also for the process we have to write begin keyword. Next is the concurrent statements. So first is S bar, not S, at the inverter. Next is S1, S bar and A. Next is S2, S and B, and last is Y, S1 and S2. Also we have to end the process statement. So using the end keyword and following with the keyword process. At last we have to end the architecture. So last is a structural style of modeling. It is the representation of a circuit in terms of interconnected components. This style of modeling corresponds to the most detailed levels of representation of a circuit. In this modeling style, architecture is essentially consists of component declaration and component instantiation. So first is component declaration. A component declaration is similar to the entity declaration, specifies each and every component to be designed in the design. Here each component is declared with its unique name, number and the mode of input, output ports and the type of ports. The component declaration is done in the declarative part of the architecture body. Here is the syntax for the component declaration. As same as the entity, we have to write component keyword and then component name and port, and here is the mode of the port name, and at last we have to end the component. Next is component instantiation. Component instantiation is nothing but mapping between actual and formal ports in the entity with the ports of the component. Here is the syntax for the component instantiation. First we have component label is an identifier, and the component name is the name of the component, and at last association list, which are the different signals, inputs and output ports which are using at the gates. Here is the example of structural style of modeling. In this also we have designed 2:1 multiplexer using structural flow style. So first is architecture keyword, and this is the name of the architecture, and this is the name of the entity. So first we are using component declaration. So first is component, and then is component name, then port, this is the inputs, this is the output, and at last we have end the component. Next is OR component, then port, then inputs, then outputs, then end the component. Then inverter, then P is the input, then N is the output, and at last end the component. Next, here is the different signals which are using in the 2:1 multiplexer. S bar, S1 and S2 are in the standard logic vector which I have used in the 2:1 multiplexer. Next is the begin. So A1 is the name of the component instantiation, and N2 is the component name, and then port map, then the association list. A and S bar is the input and S1 is the output. Then A2, another AND gate which I have used in the 2:1 multiplexer. Then N2, then port map, then B, then B and S are the inputs and S2 is the output. Then inverter, S is the input, S bar is the output. Then OR gate, S1 and S2 is the input and Y is the output. At last we have end the architecture following with the architecture name. So thanks for watching. For any queries, suggestions or questions, go to the link as mentioned in the website.